Hi everyone, welcome to week 9 of distance learning. This week we're going to be focusing on solving log equations. So the last 2 weeks you've been looking at what a logarithm is, you've been rewriting it between log and exponential form, and then last week we looked at some of the properties. This week we're going to use a combination of rewriting from log to exponential form and using those properties of expanding and condensing to kind of help us solve equations that have logarithms in them. So our first section is going to be focused on rewriting something from log to exponential form in order to help us solve the equation. So all we've been doing up to this point is kind of simplifying and rearranging things. Now I'm actually going to be finding a value for x. So let's look at number 1. So in this equation, just like we did in the last couple weeks, whenever you've got this log statement where you have one logarithm is equal to a number, you can rewrite that into exponential form. So I'm going to go ahead and do that using my little snail trick. So my base here is 7, my exponent is 2, and that's equal to x. So this equation is saying 7 squared is equal to what number? Well, 7 squared is the same thing as 7 times 7, which is 49. So that means that x is equal to 49. Now, something that we have to do with log equations. When we first introduced logarithms to you, we talked about the domain of a log function, and we said that it goes from 0 to infinity. So something to note here, a rule is that you cannot take the log of a negative number. Okay, so I'm just going to plug this x equals 49 back into my equation, and I'm going to make sure that I'm not taking the log of a negative. So I'm going to do log base 7. Instead of putting an x, I'm going to replace it with 49, the solution that I got, equals 2. So whatever is in these parentheses cannot be negative. 49 is a positive number, it's not negative, so I'm good to go. That x equals 49 is truly my answer, okay? Let's look at number 2. So we're going to do the same thing here. We're going to rewrite it from log form to exponential form. So I'm going to do my little snail trick. So I'm going to have x raised to the 0 is equal to 2. So this is saying that some number x raised to the 0 power is equal to 2. Our hint here is that any number raised to the 0 power is equal to 1. I know a lot of you have the belief that any number to the 0 power is 0. That is not correct. Any number to the 0 power is 1. So this is going to be 1 because any number x to the 0 power is equal to 1. So I'm just going to rewrite x to the 0 is equal to 1, and then that's equal to 2. So now this is saying that 1 is equal to 2. That makes absolutely no sense. So since this is a false statement, we're going to say there is no solution. So when you're solving these and you get something that doesn't quite make sense, like the two numbers aren't actually equal to each other, but they claim to be, and it's a false statement, that means you have no solution to that problem. Okay, next one. Now we are going to rewrite into exponential form. So I'm going to have base 2 raised to the 4th power is equal to x minus 9. Now my recommendation before you start any more solving is to get rid of any exponents possible. So right now you've got 2 raised to the 4th power. 2 raised to the 4th power is 2 times 2 times 2 times 2. That gives us 16 equals x minus 9. Now to get x by itself, I'm going to add 9 to both sides. And this gives us 25 equals x. So I have x is equal to 25. So I'm going to check my solution. I'm going to substitute that 25 back into the equation. So instead of putting an x there, I'm going to put 25. So what we have in parentheses now is 16. 16 is a positive number, so we're not taking the log of a negative here, so x equals 25 is our answer. Okay, let's look at the last one in this section. So before you start solving anything, we want to get that log statement by itself. So I have the 15 plus that's in the front. I'm going to go ahead and subtract 15 from both sides. Okay, my log base 2 still has a number in front of it. So to get rid of the 2 that's in front, I'm going to divide both sides by 2. Because right now this is saying 2 times log base 2. To undo that multiplication, we're going to divide. Okay, now that we've got that log by itself, I can go ahead and rewrite that into exponential form. So this is going to be 2 raised to the 5th is equal to x. So this is saying if I multiply 2 together 5 times, 2 times 2 times 2 times 2 times 2, that's going to give me my value for x, and that's going to give us 32. I want to substitute that 32 back into the original equation and make sure that I don't have any negative numbers I'm taking the log of. In this case, you really only need to worry about the part of the question that has the letter in it, because the 15 that's in the front here, I'm not going to be substituting that for another number, and I'm not going to be substituting the 25. So really all I care about is that whatever is in parentheses is not negative. So I really only need to take the chunk of the equation that could possibly give me a negative in parentheses. If you want to rewrite the whole thing and check to be sure it's true, then you can absolutely do that, but just kind of as a shortcut, you don't need to. So I'm just going to worry about the red boxed part. So I'm going to do 2 log of 2, and then we said that x was equal to 32. So when I look here, the number that's in the parentheses, 32, that's a positive number. So that's a valid solution. I did it correctly. In the next section, we're going to use the idea of logs and exponentials being inverses of one another, and the idea that they cancel out the action of one another in order to solve these problems. So on number 1 here, when I'm looking at this, I would be thinking this is asking 3 to some power is equal to 30. What is that power? Power is not 10, and I want you to think that. 3 to the 10th power would be multiplying 3 together 10 times, not multiplying 3 times 10. So x is not equal to 10. I can't think of a number off the top of my head. 3 squared would give you 9, 3 cubed would give you 27, 3 to the 4th power is 81. So there's not a whole number that I can easily get to. So what I'm going to do here is I'm going to take the log of both sides, but I'm going to take log base 3 of both sides. The reason that I'm taking log base 3 is because the base of my exponential function here is 3. So this is going to be log base 3 of 3 to the x equals log base 3 of 30. So really all I've done is apply a log base 3 to both sides of the equation. Now what's going to happen here is the log base 3 that's here and the 3 that's here, they're going to cancel each other out because logs and exponentials are inverses of one another. So think of it like addition and subtraction cancel each other out, multiplication and division cancel each other out. A log base and the exponent having that same base is going to cancel out. So all I'm left with is that exponent of an x equal to log base 3 of 30. Another way you could have approached this problem is just from the beginning, just rewrite it into log form. It was originally given to you in exponential form. If you rewrote it in log form, you would get here as well. So either idea is going to work the same, okay? That is going to be something that you're going to have to type in a calculator. Just because I know a lot of you don't have a calculator, you can just leave your answer like that. So just put log base 3 of 30. Okay, let's try another one. So on the next one, we've got 10 raised to the x minus 4 is equal to 34. I want to get that 10 raised to the x by itself before I start doing anything. So to get rid of the minus 4, I'm going to add 4 to both sides. So we've got 10 raised to the x is equal to 38. Now, to get rid of that base 10, I'm going to take log base 10 on both sides. So I'm going to take log base 10. Again, the reason I'm taking the base of 10 is because the number that's the base here is a 10. And then same thing on the other side. Okay, so what's going to happen is this log base 10 and this number 10 are going to cancel out. You're going to be left with x equals log base 10 of 38. And remember when we did the intro to logs, if you write log base 10, that is the same thing as just writing log with no base. If there's no base there, it's implied to be a 10. So my answer is log of 38. But we know in our head that there's a base of a 10 that's there, it's just not written. Okay, let's try number 3. So I need to get rid of that plus 14. I'm going to subtract 14 on both sides. So this is 5 raised to the x equals 7. So at this point, since the base of my exponential is 5, I'm going to take log base 5 on both sides. Again, base 5 because this number is 5. You're going to take the base of whatever number has the x attached to it. So like on this one, I wouldn't take log base 7 because the 7 isn't the number that has the exponent of an x attached to it. Okay, forgot my x. All right, so now these are going to cancel, and you're left with x equals log base 5 of 7. And I can't simplify that any further, so I'm just going to leave it like that. Okay, last one on this section. So here we've already kind of got everything on the same side. So I can go ahead and take the log base. So I'm going to take log base 19 because the 19 is the number that has the exponent on it. So these cancel, and you've got x plus 4 equals log base 19 of 3. And remember, I'm trying to get x by itself here, so I need to get rid of the plus 4. So I'm going to subtract 4 from both sides. You are not going to subtract 4 from the 3 that's in the parentheses. If you think back to when we did like square roots, and whenever you were solving, I told you that that square root symbol was like a locked door, like a jail cell. Nothing was going in, nothing was coming out of it. Same thing here. If you've got something in parentheses that's included with that log, you cannot add or subtract away from that number, okay? So this is going to be x equals log base 19 of 3 minus 4. And that minus 4 is going to be written on the outside. And that's your answer. Okay, the last case that we're looking at is called the congruent basis property. Congruent just means the same. So since the bases of all these problems are going to be the same, they're a little bit easier to handle than some of the other ones. So let's take a look. So the logic behind this is kind of the opposite logic of what we just did. What you just did was taking the log base of both sides based on the base of the exponent. Here, you're going to do the opposite. So you're going to look at the base of the log. In both cases, the base is 7. So what you're going to do is each side, since the log base is 7, you're going to go 7, and then you're going to raise it to whatever was originally there. So this whole log base 7 of 3x plus 5, that's all in the exponent. Same thing on the other side, base 7, and then the rest of the stuff goes on top as an exponent. So now what's going to happen is the 7 and the log base 7 are going to cancel out on both sides because exponentials and logs are inverses of each other, so they cancel each other out. And then you're just going to be left with whatever is here in parentheses. So now we've got 3x plus 5 is equal to 8x minus 12. So I just want you to understand before you just start canceling stuff out, the why behind you're allowed to cancel. And it's because you're taking both sides and we call it exponentiating. You're exponentiating both sides. You're taking whatever the log base is and you're making that the base on both sides in order to cancel out the log that's already there, okay? So here, I'm just gonna move stuff around. You can choose to move whatever you want. Your goal here is just to get all the letters on one side and all the numbers on the other. So I like to keep things positive. So I don't know, let's subtract 3x from both sides first. Okay, and then I'm going to add 12 to both sides. And then divide both sides by 5. So we get x equals 17 over 5. Now since I am solving a log equation again and I'm no longer solving an exponential equation, I want to be sure that whatever answer I got is not going to give me a negative inside of parentheses. So I'm going to go ahead and substitute this in for the two x's that are in my equation. So I'm going to have log base 7, 3, if you put this in your calculator, it will tell you true. Or if you individually evaluate each side of it, it'll come out as an actual solution. So 17 over 5 is our solution. Okay, on number 2. So the shortcut that I was talking about is whenever you see that the log base is the same on both sides, like this one has a base of 12 on both sides, just get rid of the logs and set the parentheses equal. And the reason that you're allowed to do that is because of that additional exponentiating step I showed you on the last example. What you're really doing here is giving both sides a base of 12 and then canceling the log. We're just not showing the work for it. We're skipping that step, okay? So here, I'm going to subtract x from both sides. Add 2 to both sides. And divide both sides by 3. So I get x is equal to 4. So if I substitute this back in, I'm going to get log base 12, 4 times 4 minus 2 equals log base 12, 4 plus 10. And if you plug them in your calculator or you evaluate both sides by themselves, you're going to get a positive number. So x equals 4 is my solution. Let's look at number 3. So I'm going to cancel the log base 7s. Subtract 3x from both sides. Subtract 3 from both sides. Divide by 2, and you get x equals 4. Okay, so let's check that. If I substitute a 4 right here, and I substitute a 4 right here, you're going to get that both of them turn out positive, so x equals 4 is our solution. All right, last part. I'm going to cancel the log base 4s, set the parentheses equal. Let's add 2 to both sides. I'm just trying to keep my numbers positive. You can move whatever you want to. Just make sure your stuff stays positive. And I've got 3x plus 8 minus 3x on both sides. This gives us 4x equals 8. Divide both sides by 4. And 8 divided by 4 is going to give us 2. So if I substitute 2 back in, 7 times 2 is 14, minus 2 is 12, which is positive. And if I substitute a 2 in here, that's also going to turn everything positive. So no negatives inside of the parentheses, so x equals 2 is my actual solution. None of the examples on the notes turned out to have something negative inside of a log. I just want to give you an example. So I just kind of made this one up off the top of my head. Since the bases are the same, we can cross out the logs. You would have 2x plus 1 equals x minus 2. And then as I solve this, I'm going to add 2 to both sides. Subtract 2x from both sides. And then in order for me to get the negative sign away from the x, remember this is like a -1. If I divide both sides by -1, that's going to give me x is equal to -3. So if I try to take -3 and I substitute it for either of the x's that are there, I would have log base 5, 2 times -3 plus 1, log base 5, -3 minus 2. So the issue here is that I would end up getting 2 times -3 is -6 plus 1 is -5. And then equals -3 minus 2 is -5. So even though it says the same thing on both sides of the equal sign, the issue is that I've got a negative number inside of those parentheses. So if I gave you this problem, you would get the answer x equals -3. Since -3 does not actually satisfy the equation, that's called an extraneous solution. So for this problem, we would say there is no solution. Please let your teacher know if you have any questions. Thanks for watching. I miss you all so much. Have a great week.